Hey, what's going on? I am back with another proof of concept. I actually got a lot of work done. It's not completely done, but I'm getting really close. So before we start blabbering, let me show you a quick demo. Let's see. First we'll go to light mode and then crank it to max. Excuse me. As you can see, using the IR remote, I can turn the brightness down or up in 5% intervals. Or if I just, that's using left to right, if I use up or down, it jumps straight to max or min. Or you can jump to specific intervals. And I intentionally designed it to where 75, 100, 75, 50, 25, and 0 don't use PWM. So those are the settings you'd want to use if you're doing something, if you're measuring something sensitive with the oscilloscope and you don't want the PWM noise. Because as you know, PWM at 50% duty cycle is basically a square wave, and you send a high current square wave through a wire and it'll act like an antenna. And I did some testing with my oscilloscope, which sits directly above where the LED lights are mounted, so it does definitely pick up noise. So this will be handy. So since it's at 75%, you should only see 3 of the 4 strings on, and that's how it gets 75% brightness without using PWM. So I'm going to aim the camera back up, and then I'm going to change the brightness to 50%, and then watch, you'll see that only 2 of the strings will be on. So then if we go down to 25%, it'll just be 1 single. And then obviously off, we'll have none of them. And max will have all of them. Okay, so that's the demo of the lights. And I have it to where on the remote, A goes to light mode, B is fan mode, C is power mode. Power being control to the 2 outlets that my soldering iron and hot air reflow station will be plugged into. So I can set a timer, and then after that amount of time it automatically shuts the outlet off, just as a safety measure in case I forget to turn it off, because yeah, safety first, don't want to burn my house down. B, fan mode, by that I mean the fans in the back of my instrument rack. There's 4 PWM fans at the top that basically get the air out in the back area of my instrument rack. And so let's look at that part now. So anyways, this is the main screen. Shows you what the lights are set at, what the fans are set at, and what the 2 power outlets are set at. The first one is soldering iron, second one is hot air reflow station. And then if you look over here, you'll see that I have the time. I don't have any kind of a clock in my lab, so, well, besides the one on the computer, but my computer's not always on. I only turn it on if I'm actually doing something on it, because it's just extra heat in the room that I don't need. So anyways, I have this little guy right here. It's a real-time clock module with its own button cell battery, and I have it connected using I2C. And actually, I'm using the first demo of this that I showed you, I was using some MOSFETs and actually PWMing the MOSFET gate to get different brightnesses. While that worked fine, the problem I had was that once I added infrared control, the library for that uses one of the timers that eats up 2 of the PWM pins, and that did not leave me with enough to control all 4 channels independently. And what I noticed was I actually had a motor shield meant to drive up to 4 DC motors or a servo or 2 steppers, I think, laying around. And if you know, DC motor control is basically using PWM. So instead of hooking a motor up, I hooked each light string up to each of the 4 motor channels. And that's connected using I2C also with a different address. So basically that was a way for me to not use any PWM pins on the Arduino itself and be able to control 4 different channels of PWM, which is what I use to control the lights. Let's see, that still leaves me with, I think I have 4 or 5 PWM pins available for whatever I want, and it's actually what I use to control the fans. Now, all 4 fans are running at the same speed. I run them in parallel. There's no need to control each one individually. They're just spaced evenly apart at the top, back of my instrument rack, so I just want them all running at the same speed. So I do have a MOSFET driving low side for the fans, to where when it's on off, it actually cuts its source to ground. So it is actually off. Now if I hit up, when it goes to silent, that actually switches the gate on, which gives it a connection to ground. And then I have a separate pin that also controls the PWM. And so that's what this wire is. It actually goes up over to the back of my instrument rack where my 4 fans are, and I just made a little daughter board that breaks out to 4 4-pin fan connectors. So the gray wire here is the PWM. The yellow one drives the gate of the MOSFET to turn the entire fan assembly, I guess you'd call it, on or off. Red's 12 volts, ground is black. So that's what this is. So anyways, it's on silent right now. These fans are incredible. So with, okay, I guess I can show current. Okay, with the fans turned off and the lights cranked, the lights by themselves are drawing 1.38 amps, which is a pretty good amount. Now we're going to crank the fans. Check out this current. Oh. Check out that current draw. We'll turn the lights off. So all 4 fans together draw about 1.5 amps, which is pretty crazy. And then when you have the lights cranked too, gets to about 2.3 amps. That's a lot more than I was anticipating, but man, those fans have some balls, and I will show you. Actually, I have it loop around, so silent, medium, high, and then if you keep going up, it loops back to off. Or you can go the other direction, off. Just a kind of a handy feature for a UI to have. And when you hit these buttons, it takes you into each submenu for like lights, fans, power, and I think I have it time out at about 5 or 6 seconds, and then it goes back to the main menu. What I plan on doing, but I haven't done yet, I'm going to make it to where when you push the middle button down here, when you're done making your selection, it'll automatically go back. And as you can see, using the real-time clock, I actually update this every second. I have a variable, and then I take the milliseconds timestamp. It's basically the timestamp since the sketch started running. Well, anyways, I take that, put it in a variable, and then after the difference between the current time in milliseconds versus the one stored in the variable is greater than a second, then I update it. That way I'm not updating it more than once a second. But it's cool that you get live data updated to the screen, but I have plenty of CPU cycles to catch stuff like my button pushes. But technically that's using an interrupt. So, but the interrupts are just to catch which button was pushed and read, but I actually have different logic in there to figure out what was pushed and then act upon it. So I think that's it for the fans. Oh, I was going to show you the power of the fans. Okay, so I don't have the lights on in my room, but this is just a piece of tissue paper hanging. And watch, I'm going to crank the fans to max. And the fans actually, I give them immediate PWM. I don't do any ramping, but the controller built into the fans themselves, I think they know because they're high current fans that they needed a ramp, else they're going to be cooking a lot of motherboards. So anyways, I'm going to go set fan to high. Look at that. I mean, you can feel the air. And we'll set it to off. There, now it actually has to pull it in with a little more effort, and watch, it'll still be able to do it. That's how much. I'm talking, I could put it over here, I could put it anywhere. If you put your fingers up here, you can feel the air. It is crazy. So I'll go back to high. It is a ridiculous amount of air that those fans move whenever they're cranked. A lot of current. Medium, I haven't fine-tuned this yet, but medium is for me going to be whenever. Actually, I'll probably never use medium. To be honest, I'll probably use silent for when I'm using any instrument except my DC load. And then when I'm using my DC load for a really long load test, I'll set it to high. I guess if it's a short test, I could just do medium. And then if I'm doing a long test, I'll do high. But anyways, enough blabbering about that. Sorry, I'm going to switch hands. My phone is getting heavy. I really need to get a real camera and a tripod so I don't have to do this. The third submenu, when you hit the button C on the remote, I have that set up for power, which is to be able to control the outlet timers that, well, it's not an outlet timer, this is going to control the timing of the outlet turning on and off. I don't actually have that wired up yet. I have the ability to go in and change the times, it just doesn't actually count down, and then it doesn't actually switch anything. I don't have anything. I have the pins determined already and set in the software, or in the firmware, I guess, more technically speaking. But I don't have anything connected to it. What I do have is the SainSmart. You can get them on eBay for pretty cheap. They're actually pretty nice for what they are. It's a relay board. It just has 2 relays on it. It's got kickback snubbing diodes. It's got a resistor. It's pretty nice. It's not too bad. And can't tell. Might even be an optocoupler. I can't tell. It's too dark in here, and I should have left the lights on. But anyways, you can basically connect this directly to your Arduino. You know, normally when you drive an inductive load like the coil to a relay, you know, you gotta have a diode to eat the kickback, the really high voltage kickback, which can fry your Arduino. But this has all that built in. All you gotta do is hook your load on this side. You got normally open, normally closed, and common. And then you have ground, and then you have the 2 pins. You send it high, and the relay closes. So I'll probably hook this up, because it's kind of perfect. I have 2 solid-state relays that I'm going to be using for actually controlling my soldering iron and reflow station, which are right over there. And this happens to have 2 relays on it, so you'll be able to hear it. So just for demonstration purposes, I'll probably wire this up, and then you'll hear them click on or off, as well as seeing, you know, it counting down and turning off on the screen for the next demo that I do. Hopefully tomorrow, if all goes well. I've been kind of slacking. I've been kind of hung up on the code. I think it's over 700 lines of code now, and I'm actually running out of memory. I think 28 kilobytes is the maximum, and I think I'm at 25 kilobytes, so I'm kind of cutting it close. I almost should have used the Due or a Mega, but so far the Leonardo is working, and it's actually a cheaper one. So that's what I'm going to wire up. For right now, though, I don't actually have it hooked up like I just said, but I do have the ability to go change the amount of time. So you hit C, and then you hit up or down, and then you'll see the little asterisk. That shows you which one you're editing. So it's on soldering iron now, so if you hit... Oops, I didn't realize I allowed it to circle around. See, if I hit left, it goes down. If I hit right, it goes up in 5-minute increments, and then the max is 30. And then if you go down, here, let me move that closer. So if I go down, then I can control the timer for that, for the rework station. So we'll set that to 25, we'll set that to 10 or 5, and then we'll let it go back to the main menu, and you'll see the changes there. See? So you have 25 minutes for power 1, power 2 is 5 minutes. And so once this is wired up, what it's going to be, let's say I have something quick to solder, I would just set Well, here we'll pretend. Okay, I'll let it go back to the main menu. So if I wanted to go solder something really quickly, I mean really quickly, just turn it on, solder two little things for something with through hole, and then that's it. I would hit C, and then I would just hit right. It's on 5 minutes, and then that's it. That would immediately turn. You know, actually, I probably shouldn't do it immediately. I should probably set it to where when it gets back to the main screen, then it clicks it on. Anyways, right now the solid state relay would be turned on, and then the outlet for power 1, which is what my soldering iron's connected to, would then be connected to the mains, because that's what I'm going to switch it with the solid state relay, which is in the mail and should be here Tuesday, I think. So anyways, that'll be counting down internally, and I'll have this refreshing once a minute on the screen, or maybe several times a minute. Yeah, probably every 10 seconds or 5 seconds, maybe even once a second if it doesn't need too many clock cycles. And then once it gets down to 0, it'll turn the solid state relay off. So even if I forget to turn my soldering iron off, this will turn the actual outlet off to where the soldering iron loses power. So pretty handy, and it'll be, as long as I do it correctly and safely, it'll be a nice safety feature to have. One thing I didn't do, and I might not be able to do due to lack of enough memory, is I was going to do a temperature sensor in the back of the instrument rack. So if I forget to turn the fans on and it starts to get hot back there and it breaks a certain threshold, I was going to have the fans kick on automatically, maybe make a beep or something. But I mean, I've already baked in way more functionality into this than I originally planned. But yeah, it's fun, and if I'm burning an entire Arduino on this, I figured I should squeeze every ounce of power and memory out of the thing, which so far I kind of already have, as you can see. So I got a clock for my Workbench now. I have the ability to control 2 timed outlets separately. I do have one of those Belkin outlet things. Let me see if I can find it. Well, I don't know where it is, but it's one of those things where you plug it into the wall, you plug your device into it, and there's a switch on the side for 30 minutes, 3 hours, or 6 hours, I think. And then you push the button, and then it switches on, and after that amount of time, the outlet turns off. I actually got a couple of them for my wife for her flat iron, because she likes to leave that thing on accident, and that is sketchy. So this will be the same kind of deal, only I'll have 2 outlets that I can control independently of each other. So that could have been a little overkill. I could have probably just done one outlet, one solid state relay that just turns 2 different outlets on or off at the same time, because I can't really think of a time I would use one. Well, I guess I could switch back and forth if I'm doing some reflow to solder some SMD stuff, or switching back to the actual soldering iron for other stuff. I don't know. Either way, I baked in the functionality to be able to control both. I'll be able to control the fans, so if I do a load test with my DC load, I can crank that up to make sure the heat's getting out of the back of the cabinet. I can adjust the lighting, so if I'm recording a video, I can crank it up like this, so if it's too harsh. Sorry, I'm really shaky today with the camera. If the lighting's too harsh for whatever I'm recording, or if I'm testing something that has to do with an LCD screen or some LEDs and I want, you know, the lighting to be lower, I can manually adjust it. Or if I want it off completely, I just hit down or all the way up. But yeah, that was an overdone 19-minute demo of my project. But I guess I'll show you. This is just a parallel LCD, character LCD. It's 20 characters by 4 characters. And it is parallel, but I got basically one of those shift register parallel to serial things. In this case, it's the Adafruit parallel to serial LCD backpack, and it'll let you do I2C or SPI, and in this case I'm using I2C, as well as the real-time clock, and I believe this one's from Adafruit also. I really like their stuff. Nothing against SparkFun, I have a lot of their stuff too, but I seem to end up buying more of the Adafruit stuff. And then that's just the motor shield. Oh, I guess I didn't show you. Here is the the infrared receiver. It's just hooked up to a cable. The reason I permanently soldered these, since I'm using the motor shield and it doesn't have, I didn't have any solderless breadboard, it was just a really big pain to try to test everything. So I went ahead and just permanently soldered it and gave everything enough wire to where it'll reach wherever it needs to go once I have the everything done. So that obviously is long enough to go up there just for testing, but once my project is mounted, I'm gonna have the screen right over there, I think. I don't know, because I do most of my work over here where my soldering station is. And so I think that would be probably the best place to put it. I could put it on the other end of the bench, but I'm never over on that side, so I think it'd be best over there. And then I think directly above, back behind my, on the back side of the bench behind this parts drawer thing, is probably where I'll have the entire project. I'll probably put it in a project box this time, keep it nice and tidy. And I still need to tidy those cables up, pin them to the top, and then run those through a hole and then into the back so you don't see them, to make this nice and neat. And I still don't know if I'm going to do light diffusion or not. I mean, the light's pretty harsh, but it also is really nice and crisp and bright, and I do like that. So that I'm not completely sure about. But I think that's it. So the motor shield at the top here, you see where the power goes into it, and actually there's a jumper and they give you some options as to how you want to drive it. If you use the barrel jack for the Arduino, they let you put the jumper on and use the power from there. Or if you want to use separate power and then just tie the grounds, you pull the jumper, and then that's basically what I did there. And for the final project, I almost forgot. These are so handy, by the way. If you do Arduino stuff, especially the 5-volt Arduinos, this is called a BEC. In RC and radio control stuff, this is basically what you use. Your batteries typically run like 7.2 volts up to 12 to even up to 22 volts, depending on how many cells your LiPo has, your LiPo battery. So this end you connect to your actual battery, or actually not on the battery, but the side your battery connects into. So this gets the full, input gets the full voltage of your battery, for example 22 volts, and it's actually a buck converter. So it takes that and then converts it down to 5 volts, and they're actually pretty decent current. This one is 3 amps, so it's 5 volt 3 amps. That's pretty damn good. 15 watts out of this little guy, and that, as you can see, is one of those Futaba connectors. But instead of using that, I'm just gonna, well, actually I guess I could probably put, I don't know if the spacing is, the pin pitch on it is, it'll probably work with 0.1 inch headers, but I'll probably just do headers and then plug it in. That way I can just use a single 12 volt wall wart, and then use this to get the voltage down to 5 volts for the actual Arduino side of things, and then that should be able to power my entire project. That's if I can find a wall wart with enough current. Obviously, you saw with the lights and the fans cranked, I think it was drawing, what, 2.5? There we go, high. So 2.3 amps, and as you can see, the lights are cranked, the fans are cranked. So, I'll turn that down a little. Okay, so that means I probably want a supply that's at least 4 or 5 amps, just to make sure I have overhead. I don't want it getting hot. I don't have to worry about it. I don't want a fire. So that could be tough. I know I have a bunch of wall warts that are 12 volts, but I don't think any of them do 4 or 5 amps. But I'm sure if I get online, I can find something. In worst case scenario, I can just get a really small computer power supply, because those will do 12 volts. So that would be way bigger than I need, but either way, there's options. So that's it. I'm not going to cover the code in this video because it's already 25 minutes long because I love to blabber about this shit. Probably in the final video. I mean, the code, it's 700 lines, so to cover that, it's going to take me a good 30 minutes if you want a decent explanation of what everything in the code does. And it's kind of, you know, I added one feature at a time, and so I kind of went back and added onto the code, and when you take something and then you add to it, it gets kind of messy, so I need to clean it up a little. I mean, it was pretty neat, lots of comments, but man, at 700 lines, it did start to get a little messy again, so I'm going to definitely clean it up once the project's completely done, and in the very final video, I'll go over the code, and then I'll upload it and share it with everyone, as well as links to the correct libraries that the sketch requires if you want to try to replicate this project. But for this, that's it. It's just a demo of what I have done so far. Tomorrow I might upload a quick video demonstrating the timer function, switching these relays on or off, just as a proof of concept. And if I do that, hopefully I'll get that uploaded. If I'm lucky, I'll upload this tonight, but as you can see, it is already 3:09 a.m., so can't guarantee I'll get this uploaded tonight. But that's it. See you in the next video.